Hello, welcome. So here I will be demonstrating the circuits, which are many, that I have created. I will be starting off with my arithmetic circuits. So here I have the ladders cascading into each other, and its use, as stated here, is to add two 4-bit numbers. Off to the side, I went ahead and I did the same exact thing with its internal circuits, with the circuit schematic. But just to demonstrate, here it is over here and to the side. Here is what is inside my full adder. You can see from my CIN, for the first full adder, it's connected to ground. From C out, it's going to go into CIN, following all the way down. So everything is listed from its least significant bit to its most. So I want to add two numbers. I want to add I'll add 1 and 2, which will give me 3. So A is going to be my 1. So 0, 0, 0, 1 plus 2. So B will be my 2. 0, 0, 1, 0 gets me 0, 0, 0, 1, 1, 3. I want to also do 4 plus 4, which will give me 8. Easy enough number to remember. I will get 0, 1, 0, 0, 0. And it'll be the same thing if I demonstrate with my big ol' logic circuit off to the side here. Okay, and next I will be showing my subtractor. So let me go ahead and show the internal subtractor. Here we are. Same thing as what I have off to the side. Whoops, that's for later. Here we are. So this is a simple 1-bit subtractor. So I'm going to go ahead and start off with 1 minus 1 minus 0, which will give me 0. So A will be set to 1, as well as B0, which will give me 0, 0. I'm going to do 1 minus 0 minus 1, which will give me 0. So A will be 1, B0 will be 0, and Bn will be 1. Gives me 0. And we'll do 0 minus 1 minus 0. So A will be set to 0, B0 is set to 1, and Bn is set to 0, which gives me 1 in both outputs. Now I'm going to do 0 minus 1 minus 1. So A will be 0, B0, and Bn will be set to 1, which gives me 0, 1. And it would be same for my, and here is my multiplier circuit. It multiplies 2 bits together. So I'm going to do something simple. I will do 2 times 2, which is going to give me 4. It's from least significance to most. So 2 times 2 gives me 4. How about 2 times 1? Gives me 2. 1 times 1, or I guess 2 times 2 is 4. Let me switch this up right here. There we are, you get 1. And let me just show the inside of my multiplier. Here we are. And it would be the same as how I do it out there. And here I have 2 comparators. I have a 2-bit equality comparator and a 3-bit inequality comparator. So I'll start off with the 2-bit equality comparator. So this will accept 2 numbers that equal each other, and if it does equal each other, it's going to output as high. So if A0 and B0 equal each other, it's going to output as high. It'll output as false if A0 is equal to A1, and if A0 is equal to B1. A1 will output as true if it is equal to B1. Let me just show the internal circuit schematic I have for this little design I've created. So it's going to be right here. I have so many. And it'll be the same thing. If A1 is equal to B1, output is true. False if it's equal to A0, output is false, equal to B0. A0 and B0, output is true, would be false, equal to B1. And next, I have my 3-bit inequality comparator. I had much more fun creating and working with this one than I did the 2-bit. I just find it, I guess, more appealing. So with a 3-bit inequality comparator, depending on which of these conditions is met, it will output as true. So if any of my inputs are less than B inputs, it's going to output as true right up here. If my A input is greater than the B input, output is true here. And if they are equal to each other, it's going to output as 1. I mean, if A0 is equal to B0, it output as A equals B, true, A1, B1, A2, B2. And as we can see, of course, it's all listed from least significant to most. So let's say if I want to do my A input is greater than my B, I'll set my A input equal to 3 and B is equal to 2. Of course, 3 is greater than 2, so A is greater than B, that will output as true. But what if my A input is less than my B input? So I'll set A equal to 1 and my B input equal to 2. I'll just switch it up. And there we are. Oh, let me show the internal, my circuit schematic for it before I end this video, this part of the video. Okay, as you can see, it is huge, a lot of wires. I try to make it look as pretty as I could. And of course, it's going to work the same as the other circuit. As you can see, my inputs are kind of everywhere, but it'll still work the same. So if B0 is equal to and A0 equal to each other, it's an output as A equals B, B1, A1, and if A is less than B, so I will set A equal to 1, B is going to be 2, A is less than B, and if A is greater than B, I will set A equal to 3 and B is equal to 1.